Learn about tangents. So what are tangents? A tangent to a curve is a line through P with the same gradient as the curve. So let's draw a tangent there. So that's a tangent. Okay? It's a line that touches the curve at one point. And the gradient of the tangent is equal to the gradient of the curve. Another way you have to learn is called the normal. Normal is a line perpendicular to the curve. Perpendicular. That's called normal. So you have to learn these new words. And how do we find the equation of the tangent? We use this formula on your reference sheet, point gradient form. Alright, so let's look at some examples. Okay, so find the gradient of the normal if the tangent gradient of the tangent is 5. So if the normal is perpendicular to the tangent, what would you do? Okay, alright. So what you do is we're going to do, if they're perpendicular, gradient of tangent times the gradient of normal is -1. Therefore, to get the gradient of the normal, you divide it by the gradient of the tangent. Yep. So you do. So the gradient of the normal will be -1/5. Alright, try the next one. Alright, so what's the gradient of the next one? Gradient of the normal? So it should be 4. Right? E negative reciprocal to -1/4. And then the next one, -4/3. So you switch the numerator and denominator and put a negative in front. Okay, once we're done, then we'll do example 10. Example 10 is find the equation of the tangent normal to the curve at this point. So the tangent is in red, and the green one is the normal. So we're going to find the equation of both. Let's start with the tangent. Alright, so to do this, what you do first is find the derivative, which is 0 minus 2x. Hopefully remember the rule from Friday. -2x. Once you find the derivative, we're going to substitute the point in 1, 3. So you substitute the x value. So the gradient of the tangent will be -2 times 1. That will just be -2. That's gradient of the tangent. And once you get the gradient of the tangent, we can find the equation y minus y1 equal to mx minus x1. Yep. And then do y minus 3 equal to -2 x minus 1. And then if you expand this, you get -2x plus 2, and therefore you get y equal to -2x plus 5. That's the equation of the tangent. Okay, get the idea? Okay, next one. Let's find the equation of the normal. Now to get the equation of the normal, first get the gradient of the normal, and they're perpendicular, so it's -1/mt. So you get -1/-2, which is half. And to get the equation, you do y minus y1 again, but this time the gradient is half. Like that. And then you're going to expand, so you get half x minus half y equal to half x plus 3. That will be -5/2. Alright, that's the equation of the normal. Alright, any questions? So it's pretty basic, things that we learned last chapter, the equation of the line. So to get the gradient, you have to find the derivative, substitute the point to get the gradient of the tangent. Gradient of the normal is the negative reciprocal of the gradient of the tangent. Okay? Oh yeah, you're right, plus. You're right. Thank you. Alright, after you do this, we'll also have to find the angle of inclination of these two lines. So the angle of inclination is this angle. Tangent and normal. And there's a rule to do that. Gradient tan theta equal to the gradient. Yep. So tan of the tangent is equal to -2. Because the gradient of the tangent is -2. And because it's obtuse, you have to do 180 minus the related angle. And then use your calculator. Alright, so 116 degrees, 34 minutes. Yep, okay, good. How about the angle of the normal? You do the same thing, but this time is equal to half. And you can just work out it's going to be acute. And then use your calculator. So let's see. Shift tan 0.5. 26 degrees, 34. Okay, done. Why is it half? Because the gradient of the green line is half. It's half. Yep. Oh, because the negative reciprocal of the tangent, they're perpendicular. So if the tangent is gradient -2, the normal will be, yes, from here. Yeah. Yeah. Yep. Don't put negative because it's a related angle. Yeah. Okay, after we do this, we're going to find the points A and B where the tangent normal meet the x-axis. So the tangent meet the x-axis at A, meets the normal meets the x-axis at B. Alright. The next one is we're going to find the coordinates of A and B. So we find the x-intercept. So let's write down the tangent first. So to find the x-intercept, you do y equal to 0. And you get 2x equal to 5, x is 2.5. Okay, so the coordinate of A is now found, 2.50. A is this point, where the red line crosses the x-axis. Alright, try to find B. Use the equation of the normal. And then you get 0 equal. And then you move the 5 over 2 over. So x is -5. So your B is -5, 0. Yeah. Alright, after this we're going to find the area of this. Yeah. B is that point where the normal crosses the x-axis. Okay, good. Alright, so now we have to find the area of this triangle. Now remember we found a lot of areas in the last exercise. Okay, so we're going to find the area of the triangle. What's your suggestion? Yeah, but we don't know the angle. Actually we do, but that's not exact. It's better to use exact. So to find the area, the easiest way is to work out this length. What's this length equal to? So remember this is -5. This is 2.5. So what's the gap between them? 7.5, 7.5. Now how about the height? What's the height? 3, right? See the y value is 3, height. So how do you find the area now? Area is half base times height. So you go half times 7.5 times 3. And then use your calculator. Alright, 11.25 is the area. Square units. Alright, done. Let's move on to the next question. Okay. Yeah. Alright, all got it? Yeah. Let's move on to the next page. Quickly. Alright, next question. Find the equation of the tangent normal to this graph at the point x equal to 2. Let's find the tangent first. How do you find the tangent? Differentiate to get the gradient. So you go y dash equal 6x squared minus 2x. And then you substitute x equal to 2 in here. And then you do 4 times 6. So the gradient is 420. So that's the gradient of the tangent. Gradient of the tangent. And once you do that, you can do y minus y1 equal to mx minus x1. Now, how do I get the point? We only got the x value. How to get the point? We substitute 2 into the original formula. So it's substitute 2. Okay, so we need to get the y value. So to get the y value, we substitute 2 into x to get the y value. Yeah, where x is 2. See the one before, I gave you the point. This time, I don't give you the point, I only give you the x. So how do I get the point? You substitute 2 back into the original to get the point. So you get, what would that be? 8 times 2 is 16 minus 4, 12. So the point is, so 2, 12, right? So you do point gradient form, y minus 12 equal to the gradient, x minus 2. And then you just simplify it. Yep, it is 2, 12. And then we're going to expand 20x minus 40. And there you go, y equal 20x minus 28. Yep, got it. Okay, that's the tangent. How do I get the normal? How do I get normal? To get the gradient of the normal, you do negative 1 over mt. Negative 1 over mt is, what's mt? 20. And they use the point gradient form again. Y minus 12 equal, so the only thing you change is this, instead of 20, right? Okay, good. Now, let's get rid of the denominator, so that would have a general form. Multiply both sides by 20. So you end up getting 20y minus 240 is negative x plus 2. And the equation of the normal in general form will be x plus 20y minus 242. Right, equation of the normal. Alright, that's the full work. Let's go through this. Okay. Alright, let's move on to part B. Find also the points on the curve where the tangent is horizontal. What's the gradient of the tangent if the tangent is horizontal? 0. So that means gradient of the tangent is related to the derivative. Remember what the derivative is? 6x squared minus 2x. So what I wrote before. Yeah, that's the derivative. Okay. Then what you do is you put y dash equal to 0 to find a point where the gradient is 0. Right? Now how do I solve this equation? This is a quadratic. How do I solve it? Factorize. What's common factor? 2x. And then you get 3x minus 1. Yep. So that means tangent is horizontal when 2x is 0 or 3x minus 1 is 0. And then you get x equal to a third, x equal to 0. Yep. So these are the two locations where the tangent is horizontal, but the question asks for the point. How do I get the point? You substitute back into original formula, which is 2x cubed minus x squared. So substitute x equal to 0. And you get 0. So it will be 0, 0. And then the other one you substitute into the formula. And then use your calculator. One divided by 3 to the power of 3. 1 divided by 3. Close bracket square. You get this. Negative 1 over 27. So the other point is 1/3 negative 1 over 27. So these are the 2 points where the tangent is horizontal. 7. Yep. That's always how they draw 7. Now, it's not a full process. There's a good reason. Now, historically, why is 1 like this? there's one angle. Why is it 7 like this? 1, 2, 3, 4, 5, 6. I don't know. No, you have to have 7 angles. See, 8 was like this, right? 1, 2, 3, 4, 5, 6, 7, 8. That's why 8 looked like this. Yeah. Yeah, so the Arabic numerals related to the angles. Yeah, okay. Alright, let's move on. Alright, okay, let's move on. Alright. Alright. Alright, next question. Alright. Okay, now, find a point where the curve, where the tangent is parallel to the x-axis. So what's the gradient if it's parallel to the x-axis? X-axis is this. If it's parallel, it must be gradient 0. So therefore, you do derivative first. 2x plus 2. And then you put the gradient to be 0. Is the gradient. Yeah. Make sure you watch the video that you missed. And then what you do is you solve. X is -1. But because they say find a point, and then you do y, find the y value, and then use a calculator. 1 minus would be -9. So at this point, the tangent is parallel to the x-axis. Okay, parallel to this line, if they're parallel, they must have the same gradient. What's the gradient of this line? And then find the derivative, and the gradient of the line must be equal to this, and you solve for x. So what will x be? No, x is -2, right? And you find the y value. And then use your calculator. 4 minus 4, -8. And the last one, next one, C. Yeah, very good. Okay, good. All right, how about the next one? Perpendicular. If they're perpendicular, what would the gradient? Yep, -4 on 3. So you make that equal to the derivative, which is equal to 2x plus 2, and solve for x again. So -2 will be -10. So x is -5/3. Well, use your calculator. -2. Oops. -10 on 3. Y dash 2x plus 2. Yes. You do -4/3, subtract by 2. Get that. Alright, and then once you solve for x, subtract back into find y. And then use your calculator. So that's on the answers, so you write answer square plus 2 answers minus 8. Negative 77 on 9. So that's this point. So at this point, the gradient of the tangent will be perpendicular to this line. Okay, done. One more question. Alright, one more question. Find the value a if y has a gradient of negative 3, where x is 2. Okay, so that means y has a gradient of negative 3 means y dash is negative 3. Let's find y dash. So we do y dash equal 4 times 2 is 8x. A is a number, so write plus a. So that means when you substitute x equal to 2 in here, y dash is negative 3. So you get a plus 16 is negative 3, a equal to negative 90. Alright. Ah, that's the derivative that we'll learn on Friday. Okay. Right, that's done.